Hi everyone, we're going to graph this piecewise defined function and also test for continuity at x equals 0. So the first thing we're going to do is test for continuity. So this is the definition of continuity. It must meet these three conditions in this order. So we're going to test the first one, and they want to see if it's continuous at x equals 0, because this is where all the changes are occurring, right in these two here. So basically, the first condition is just, do we have a f of c? Now our c in this case is 0, so we just plug in 0. We have to plug it into this upper portion because this is where x equals 0. So when you plug that in, you get 0 plus 4, that equals 4. So it does meet condition 1. Now for condition 2 to work, the limits have to equal from the left-hand side and the right-hand side of the limit. So what that means is if I take the limit, and we're looking at this piece right here, the limit as x approaches 0 from the left of my function, that should equal the limit as x approaches 0 from the right. And all that means is the numbers to the left of 0 here. The numbers left of 0 fall into this function, and the numbers to the right of 0 fall into this function. So for the left of function, you just plug in 0, and we already did that. And we know that equals 4, and this should be f of x here. Now, to the right of 0, we have to plug in 0 to this equation. So when you plug that in, you get 4. So it does, they do equal. So that means the limit does exist as x approaches c. So, or to 0 in our case. So that works. Now the last condition is pretty simple. It just means our limit number that we got should equal our f of c number. So our f of c should equal the limit as x approaches c of f of x. So our f of c was 4, and our limit here was 4. So this function is continuous, and it met all three conditions. So let's graph it and see what it looks like. It means there shouldn't be any points of discontinuity. So we're at 0 here, so this is our things, x value where things are happening, our c. And let's plug in 0, and we already did that, so that equals 4. So 1, 2, 3, 4. And it can equal it, so we do a closed circle. Now, if you plug in, let's plug in -1. So if you have a table, you have x and x plus 4 for your y, or f of x. You plug in 0, you got 4. All numbers left of 0, so that's -1, that goes to 3. So I'm going to go -1, and that's going to go to 3. And since we know both of these are lines, we only have to plug in 2 points, because just draw a straight line. You also know the slope is 1, so you can kind of graph it that way. Now, for the numbers right of 0, the positive numbers, we're going to plug in 0 again. Now, in this case, when you plug in 0, and let's do this one in red, you go up here, but this is an open interval. But closed overrides open. So this is still going to be closed because it's closed because of this one. Now let's plug in 1. So you plug in 1, you get 2 times 1 plus 4, and that equals 6. So we're at 4, 5, 6. That makes sense because the slope is 2, so we're going up 2 over 1, and it goes, it's going to be like that. The slope is 2. Something like that. So there, this is why you see that the function is continuous, because you can draw on this line here and never have to lift your pen to draw the graph. And that's it. Thank you. Have a nice day. Bye-bye.